Welcome to another episode of the Breadboard Apprentice. In today's episode, we are going to start building the clock module for our computer. Let's start with looking at the requirements for the clock module. So to start with, we want to be able to send single pulses or single clock pulses to the computer so that we can step through a program a single instruction at a time. We also want a way to have a variable frequency mode. That way we will be able to speed up the clock pulses when we are not when we want to test the computer, and we can also slow it down when we want to find a particular spot in the code that is being executed on the CPU. Finally, we also want a high frequency mode driven by an oscillator, and I would really want to be able to run the CPU at 1 megahertz. That sounds like a lot, but I hope in the end that we will be able to run it that fast. And of course, we would want to be able to switch between these three modes using some toggle switch. And that is really all the requirements of our clock module as it is now. So let's get to building. To make it a bit easier once we start building the circuit, let's start by drawing a schematic over the astable configuration of the 555 timer with all the components that we will need. At this stage, I don't care to make the schematics too pretty or anything. That will come later when we are actually transferring this schematic to KiCad. Now that we have the schematic, let's think about the function that this circuit will have. Since it's a 555 timer in astable mode, it will generate a square wave. And this square wave will have a pulse width where the pulse is high, and it will have a time where the pulse is low. And these times depend on the component that we are choosing for the circuit, and can be calculated with these formulas. We can also use online calculators to calculate the time and the frequencies of the circuit, depending on the component choice. I found this one at DigiKey, and this calculator also came with the schematic that we draw up. Using the calculator, I'm a bit puzzled because the timing doesn't feel that they should make sense. I choose the component similar to what Ben Eater did in his video series, and so I know that the timing should be a lot faster than this. But let's build the circuit and we will see what the timing is, and maybe we can do some debugging of the formulas here. And now, with all the preparations done, it's finally time to gather some components and start to build. Now that the circuit is built, we do see that the timing is not quite what we expected. In fact, I can actually not change the frequency at all. So let me have a look and see if there is something wrong. Okay, I found what was going on here. We seem to have not connected the potentiometer correctly, and the circuit was broken. But let's fix that. Now we can see that it blinks as expected. Or actually not as expected, since in our calculations the frequency was very different from what we are seeing now. So let's have a look again at the formulas and the calculator from DigiKey. I of course made a mistake when I inputted the numbers in DigiKey calculator. Instead of microfarad for the capacitor value, I put millifarad. So the frequency would be about 1,000 times slower than we see. And indeed, when we're putting in the right values in the calculator, we do see the right values. That's it for today, and I hope to see you in the next one.